Welcome to our final chapter of this Crystal introduction. In the previous episode, we built a basic web application in Crystal using Camel. We will now add database access via the CrystalDB shard. The official shard CrystalDB provides a unified way to access relational databases. You will note the library is fairly unopinionated on how to make queries. It offers low-level access to query execution, a connection pool, and a very simple object relational mapping. However, it does not attempt to abstract the underlying SQL dialect. There are other libraries that offer more complex functionality, but for this episode, we'll stick with CrystalDB since we aren't going to need a full ORM. There are drivers for PostgreSQL, MySQL, and SQLite. Let's install the one for SQLite and retrieve records from a test database. Let's start by creating a DB file where we'll manage our database connection. Typically, we will move the connection string to configuration, but this will do for now. A few things to note in this module. First, see that we are declaring the database using double@. This means that it is a module-level variable. Also, its type is of a nillable database, since it is nil until the DB method is first invoked. The double colon you see in DB is required. If we left it out, the DB would be referencing hello DB instead of the shards DB. Also, check out the usage of the conditional assignment operator, which is commonly used for memoization. If add@database is not nil, it is returned. Otherwise, the DB open method is called, and its result is assigned to the database variable and returned. Let's now create a contacts table in a local database. We'll change our post action in our web app to insert a contact in the database. The key here is the call to dbexec, where we pass a query as an argument, along with the positional arguments. Always make sure to use placeholders and never use string interpolation in order to prevent SQL injections. Also, we'll make sure the database connection pool is closed gracefully on exit. To do this, we'll use the addExit global method, which will run whenever the program exits. Good, let's now test it by running a curl and checking the table contents to see the added record. We'll continue by changing the get method to return all users now. The query method returns a result set, which we can then iterate to go over its rows and read each column specifying its type. As we read the result set, we stream the fields to the HTTP response. Neat, right? However, this is fairly low level. CrystalDB provides a simple way to map result set rows to Crystal objects by specifying a mapping. We are stating here that the contact class has two fields, name and age, along with their types, and that an instance of a contact can be constructed from a result set by reading a name and an age column. We can now simplify our database access by using the queryAll method, if we don't mind loading all records into memory, that is. The last parameter tells CrystalDB how to return the records from the result set. If you didn't want to map an instance of a class, you could also have specified a tuple. Let's see it at work. That's great, but returning the result of inspecting each contact isn't very useful. We could return a JSON array here. To do that, we can either build the JSON manually by iterating through the contacts and using a JSON builder, or we could use a JSON mapping for that. Here, just like in the database mapping, we tell Crystal how to serialize and deserialize our contact class into JSON. So now we can just invoke toJSON on it and check the results. This concludes this episode, which covered the basics of building a simple web JSON API backed by a SQL database, and also this series of videos. Make sure to check the documentation for more options on database access and JSON mappings, and visit Crystal's community page to get in touch with other Crystallers and help the language grow. We hope you have enjoyed the series and the language itself. Happy Crystalling, and thank you.